Hello everyone, welcome back to another AP Physics 1 daily problem. Today we'll be going over question 14 in the MIT AP Physics 1 workbook. That'll be in the description down below for you guys to follow along. With that being said, let's go on with the question. It says vectors v1 and v2 shown above have equal magnitudes. The vectors represent the velocities of an object at times t1 and t2 respectively. The average acceleration of the objects between time t1 and time t2 was, and then it gives us our direction. So here the question is asking us what the direction of the average acceleration was, not what the value of the acceleration was. So if you guys remember that the average acceleration was equal to the delta v over delta t, so the change in velocity over the change in time. And this makes sense because a average is the same as like slope. Slope is the average rate of change in a line. So if we have a graph like this, the slope is going to be the average rate of change since it's constant. And if you guys remember derivatives is the average rate of change over time. But here we're only caring about the linear stuff because this is a constant acceleration. We're not going to assume to make it more complicated. Since it's only asking us the direction, we're going to assume that we are talking about the average acceleration, as it does say right here, average acceleration. So knowing that average acceleration is delta v over delta t, finding that, we would just do a average is equal to v2 minus v1 over time t minus time 1. Now when you do this, you can go ahead and plug in these directions, finding the x and the y components, and finding the y component since there's no x component there. But I'm going to show you guys a very quick shortcut to minimize doing all that components and adding them in deciding the direction. So a quick way to do this is just combining all of these two vectors into one graph. So doing so, creating our own axis, if we have vector 1, v1, if we draw at this direction, and we have vector v2, and we draw v2 in the same way, it's up. And a reminder that it says right here that they have equal magnitudes, meaning that this is working in this case. Since they have equal magnitudes, that means that they're going to cross out certain components, which is why we can do this. So now that we know that they have equal magnitudes, we want to know how do we get from v1 to v2. And doing so, we would draw an arrow. And if we draw an arrow from v1 connecting it to the arrow of v2, we can see that v2 from v1 to v2 is actually just the change in velocity, delta v. And we know that the acceleration average is equal to the delta v over delta t, and we know that delta t is always going to be positive because you're going to be the higher time minus the lower time, so it's always going to be positive. So what matters about our direction is going to be this delta v that's going to affect whether we're pointed left, right, up, or down. Knowing that the vector, the delta v component of this tip to tail of the arrow, we can see that it's not fully to the left, but it's like pointed a little up and pointed a little to the left. And if we see our coordinate system, east is to the right and west is to the left, we know that this we know that this vector, the resultant, the delta v, is going to be pointed a little north and west at the same time. And if we look at our answer choices, choice A says directed north, which is not true since we have a little y component to cancel out this east component from v1. Then choice B says directed west. That is true, but we also need to make up for this lack of the y compared to v2. Since they are the same magnitude, we need to make up for that lack with having a little north in it, so choice B is not correct. Choice C says directed north and east, which is not true because if it was north and east, it would just have the vector coming out even more, and we can tell that the vector comes from the right to the left, meaning that there is some magnitude canceling out the east, and to do that we need the opposite, and the opposite of east would be west, which leads us to our choice D, which is directed north and west, so that this west portion can counteract this east to make it completely vertically, and then we need some north to make it straight up, as we can see the lack of the y. So that leads us to choice D. I hope you guys enjoyed the video. If for any reason this was confusing or something didn't make sense, please comment down below and I would love to respond. And with that being said, I hope you guys enjoyed the video, and remember to enjoy life.